four groups remains their place. In our analysis, again, I marked Spain is not contained. The other countries change their places, but they are the leading of countries for renewable energy consumption and solar energy consumption. Now, according to this general view, we will look at the solar energy consumption, how it will affect the economic growth in those countries. And my presentation of our economic model includes introduction, literature review, data, methodology results, and discussion parts, and a conclusion. Therefore, let's start to understand what we did and what we found in economic model. First of all, why it is important, what is the importance of our study? How an increase in amount of solar energy consumption in those countries affect economic growth and in the indicated period. This information will give us an analytical approach. We can make an economic, we can provide or we can supply an economic policy from there with mathematical calculations, with econometric techniques in the indicated period. And we use here in literature, there are very lots of studies about panel data. We choose the linear form, linear regression form. There are some nonlinear and complex forms, but since we are working in this study for the last month, so we took basic models, but we are trying to improve those models, and we choose some two techniques in here, and we have a Hausmann test for preferring which one is effective for our data. We can, in this slide, you are seeing the literature. So we can, it looks like an engine of our study. When we checked the literature, we see that there's a lots of country comparisons. And what they use in here is the techniques, as you see on the last column, descriptive techniques, macroeconomic modelings, some statistics, unitary process, surveys, indexing methodology, and the idea behind all of them is just making and trying to understand both solar energy and energy consumption with market, economic growth, and indicated years, as you see, and the countries are take place generally for both developed and developing countries. And this slide shows the theoretical methodology that we use, why we choose to panel data analysis. Here you see in those recent studies the basic panel data analysis. There can be more detailed, like all of them studies are done with panel data techniques, but ours is based on production function, and also these studies can be made according to causality techniques. They are not a general, they are not reflecting a general method, but just the variations between variable in statistics. So the methodology indeed is very deep. So there should be some new studies about these techniques in future.
If you can allow us to cut your presentation to 25 minutes, because I think you are starting pretty much.
Okay, so I should okay. So yes, our method is based on a production function. Here you see the variables. Maybe you have heard about this capital, labor, human capital, energy consumption and renewable energy consumption. We express it in one mathematical formula. And then we calculated as dependent variable the GDP per capita. It's calculated by GDP divided by mid-year population, and it's taken with constant prices. And we will look how independent variables will affect the GDP per capita. And here is a general observation, general view. You see the graph in the beginning of history and from year zero and recent times. There are two things which affects GDP per capita is very much. One of them is industry and information revolution in the recent years. So therefore we choose this interesting subject. Let's see the independent variables that are affecting our dependent variable. One of them is produced solar energy. In here you see a flat plate solar collector. As you know very well, it is used for heating purposes. And Turkey and China are the leading countries in flat plate solar collectors. And the expected sign is we are curious about it, how producing solar energy in group of 20 countries will affect GDP per capita. And here you see another concept for photovoltaic systems for producing this time electricity. And its units in gigawatt hour produce solar energy. We will look at the sign. And second independent variable is gross fixed capital formation. Countries makes investments, as you see here, in some equipments, factory, the government spendings. All the data is taken from the World Bank, and we expect it should be positive. So we can consider that it can be a control variable. Here you see the gross fixed capital formation in one picture. For example, there's one airline, a modern highway, buildings, all the government spends for it. So if we increase the government spending on infrastructure, the GDP per capita, it should increase. It's a theoretical fact. And you see some countries, some developed countries, their spending on government gross fixed capital formation changing according to percentage of whole GDPs. As you see, it is changing between 2% and 5% in the indicated years. And in the third independent variable, so you are seeing the labor force, and International Labor Organization defines labor force, the people who age 15 and older belongs to labor force markets. So we are curious about the design of it, but we know some information about labor force in this field. High qualified workers are needed in this sector because there are technological devices. So in that case, the labor force should be skilled and should be educated. So we will look what is how is the effect in GDP per capita. In the fourth variable, human capital is seen the engine of economic growth. It's based on people. You educate, train, empower, reward people. The main determiners of the human capitals are education and health, and we take the health. So we count as the number of years a newborn infant will live throughout its life in years. So in developed countries, we expect this number is high, and in developing countries, this number should be low, and it is not can be expected for our economic model. But we are sure about something else. If a country make investment in education and health, you see its GDP per capita will be high for healthier and educated people.
We have 2 minutes.
2 minutes, okay.
Next presentation is just possible.
see our economic model in here. First of all, we apply to implement our data, and we determine a threshold level. It is around $30,000. We rank the countries according to GDP per capita levels, and we catch up the theory, yes, the G7s and G12 with our data. So a production function and the indicated independent variables are taken, included in our model, and renewable energy is taken as control variable. We took both sides of equations in the natural logarithm form. So this transformation provides us to obtain economic growth. I'm casting the methodology in here. This is panel data technique. What is done in panel data, but it's a very specific subject. Therefore, I'm casting it. It's used for macro panels and Hausmann test. And here are the test results we found for G20, G12, G7. If I summarize our in a one equation for different size of countries, we obtain these equations, and we summarized these equations in one solution matrix. Let me explain what is going on in here. For example, solar energy consumption affects GDP per capita. 100% increase in solar energy consumption increases GDP per capita 0.8% or 1% in G12 countries. And we found significant results at that countries, and the other measurements are as you see here. So if we discuss the empirical findings, we should use a random effects model. It's much more appropriate, but it's produced solar energy is not significant, and also human capital is not significant for those group of countries. And let us discuss all those things in a conclusion. Yes. First of all, why random effects model is preferred? Because answer, there's a development level differences in each countries, but random effects takes the opportunity us to express in a good way. So therefore, we can choose random effects according to fixed effects. Second, why produced solar energy affects G7 negatively, it affects G12 positively, but produced solar energy is not significant for G20 countries. Third, gross fixed capital, as we expect, should be increased in all group of countries. Fourth, labor force variable decreases GDP per capita, so countries should pay attention. We will explain. Fifth, since electricity produced from renewable energy positively affecting economic growth, it has changing effects on produced solar energy. And human capital is positive for G7 and G20 countries, but it's indefinite for G12 countries. And as a policy implications, what we found is labor force need to be skilled, paying attention to negative growth rates in short terms as a payoff for transition to renewable solar energy. 3. More attention should be given to solar energy use because renewable energy is one of the most important subjects of following 30 decades. And for the policy implication for the developing countries are faced with financial problems, initial cost problems, unskilled labor, infrastructure problems, the market structure problems. For example, it's not a competitive market, bureaucracy are slower, makes slowing them, and some governmental problem, for example, lack of subsidies If these preparations are made, economic growth should be much better. Thank you for your attention.